Okay, question number 2. A marble rolls across a table at a speed of 20 centimeters per second. The tabletop is 110 centimeters above the floor. Of course, the marble rolls off the edge of the table. Determine the following values using 10 as your value for G. Okay, so here's our tabletop. Here's our floor. This is 110 centimeters, which is 1.1 meters. We're going to have to convert it. The marble's rolling along at 20 centimeters per second, which is 0.2 meters per second. We have to convert it. So that's the initial velocity in the x direction, which is simply the velocity in the x direction. Alrighty, so what does it want us to know? Interval values rounded to 3 decimal places. Okay, so the time for the marble to hit the floor. So how long does it take anything to fall? So over here, vertical. So the initial vertical velocity is 0 meters per second. The change in position is, okay, I'm going to let up be plus and to the right be plus. So the initial change in position is negative 1.1 meters. The acceleration in the y direction is negative 10 meters per second squared. And the question is, how long does it take to hit the floor? So what's the time? Alrighty. So I'm going to use delta y equals initial velocity times time plus 1/2 the acceleration times time squared. So negative 1.1 equals 0 times t plus 1/2 of negative 10 times t squared. So negative 1.1 is equal to negative 5t squared. So 1.1 divided by 5 equals t squared. So t equals, let's see here, taking the square root of 1.1 over 5. Square root 1.1 divided by 5 is 0.469. So 0.469 seconds. So there's the answer to the first one. The horizontal distance the marble travels while falling to the floor is. Okay, so horizontally, the distance is going to be, so delta x equals the horizontal velocity times the time to hit the floor. So that equals 0.2 meters per second times 0.469 seconds. So 0.469 times 0.2 is 0.0938, so that's 0.094. 0.094 meters. All right, so there's the answer to part 2. Third question. The velocity of the marble just before hitting the floor has the horizontal component of, okay, well, horizontally, so v final in the x direction is 0.200 meters per second because it doesn't change. Vertically, okay, let's see here. V final in the y direction equals V initial in the y direction plus the acceleration times the time falling. So this equals 0 meters per second plus negative 10 times the time of 0.469, 0.469. So that gives me negative 4.690 meters per second. So there is the final component, or the component of the final velocity in the y direction. So this results in a final velocity, so the actual final velocity. So the final velocity has a magnitude, therefore, of this x part squared. So that would be 0.200 squared plus negative 4.690 squared, and then take the square root. So that's square root of 0.2 squared plus 4.69 squared is 4.694. 4.694 meters per second, rounding to 3 decimal places, and the angle is the inverse tangent of the y component, negative 4.690, divided by the x component of 0.200. So inverse tangent of negative 4.690 divided by 0.2000 is negative 87.558 degrees, and that would be that many degrees below the horizontal. So the actual answer to the final, since they give us below the horizontal, we ignore that negative, and that's number